Welcome to Math TV with Professor V. It's Tuesday, February 7th, 2023. Here's your integral of the day. We have a definite integral from 0 to pi over 6 of the square root of 1 plus cosine 2x dx. I actually did this one in class yesterday with my Calc 2 students, and I thought it had a nice little trick to it. So pause the video if you want to give it a try on your own. What I'm noticing is no U sub is going to help us, okay? Instead, I'm going to play around and use my double angle identity. So cosine 2x, cosine 2 theta, there's three versions of the double angle identity. I'll write off the first one to the side that you probably remember. So cosine 2 theta is cosine squared theta minus sine squared theta. But there's also two other versions of this double angle identity. If I replace cosine squared with 1 minus sine squared theta, then we have cosine 2 theta is 1 minus 2 sine squared theta. And then alternatively, if I replace sine squared theta with 1 minus cosine squared theta, watch what happens. Then you have cosine 2 theta is cosine squared theta minus 1 minus cosine squared theta. Do you see it? So this ends up becoming 2 cosine squared theta minus 1. So which to choose from? It really depends what you're doing in math. So be ready to bust out any of the three when appropriate. Since underneath the radical, I have this positive 1. I'm going to choose this last version of the double angle identity. Watch and see why. So I'm going to rewrite. We have definite integral 0 to pi over 6 square root 1 plus, and then instead of cosine 2x, I'm going to write 2 cosine squared x minus 1 dx. All right. This is perfect because now these ones cancel out underneath the radical. And I just have 0 to pi over 6 square root 2 cosine squared x dx. All right, now let's be careful here. Remember, the square root of x squared is equal to the absolute value of x. So similarly, square root of cosine squared x is equal to the absolute value of cosine x. Here's where we have to use some caution. Look at the limits of integration. They're from 0 to pi over 6. So on 0 to pi over 6, we are in quadrant 1, and cosine of x is positive in quadrant 1. Therefore, I don't have to worry about splitting up my integral or changing the sign. Absolute value of cosine x is just going to equal positive cosine x in quadrant 1. If the limits of integration included angles in quadrant 2 or 3, then you would have to possibly split it up and then put a minus sign in front of cosine. Okay, good. Just always think about it. It's not going to affect anything here, but you don't want to be careless. So we have 0 to pi over 6. I'm going to put the square root of 2 outside, and then I just have cosine of x dx. And then now, pretty easy little integral. So what's the antiderivative of cosine x? Why, it is sine x. So we have square root of 2 sine x evaluated from 0 to pi over 6. Leave the square root of 2 out. If you want to put the bracket here, go for it. And then we have sine of pi over 6 minus sine of 0. Sine of pi over 6 is 1/2. Minus 0, so final answer is root 2 over 2. And I especially loved this integral because it hinged on remembering just some basic trig identity, and it shows how important trigonometry is even as you advance in your math career. And then after that, the calculus was actually super straightforward and simple. So don't forget your trig. I can't emphasize it enough. If you need a review, I have plenty of video lectures going through all of the identities, showing how to get the double angle identities. That always helped me remember it better when I could see where it came from. So I'll link some of the playlists in the description if you need a little refresher. No shame in that. Give the video a thumbs up. Subscribe if you haven't already. Leave me a comment below what you enjoyed, what you're up to this week, any integrals you'd possibly like to see. And thanks so much for all your support, you guys. You can catch me on Instagram and TikTok too, at Math TV with Professor V. Bye, guys.